Welcome back to another episode of my derivatives examples. This is the 10th episode. This series is basically me running through 3 examples that I've written up. This is the 10th episode. From the first, continuously, I'll be writing harder, progressively harder questions and functions and stuff to derive. So hopefully these videos help. It always helps me when someone runs through questions. So here goes. These are the 3 examples, and I will do them in order. First example is y equals x squared multiplied by e to the power of x over x squared plus e to the power of x. We've got a fraction over a fraction, so we use the quotient rule. Therefore, it's going to be u dash v minus u v dash over v squared. Now keep in mind that u is going to need the product rule to solve, so we're going to have to call this one a and this one b. So we're going to derive it. U dash will be a dash b plus a b dash, and v will be x squared plus ex minus u x squared multiplied by ex. We actually don't need that. Bracket multiplied by v dash, derivative of x squared is 2x, plus derivative of e to the x is just e to the x, all over v squared, which would be x squared plus e to the power of x squared. Okay. Now, let's fill in this little section. A dash, that's x squared. So a dash will be 2x, b is e to the x, plus a, which is x squared, multiplied by the derivative of b, which is ex is b, so the derivative is just ex, and then we've just got to fill in this. Oh, can I fit that? Yes, just. Okay, now we're going to do a bit of simplifying. What I'm basically going to do is expand the brackets. So we're going to expand this out, and we're going to get 2x to the power of 3 e to the x, because I'm just going to expand them out. You should be able to expand things out before you start learning derivatives, because this is basics. I'm actually going to need more room. So expanding out, 2x to the power of 3 e to the x plus 2x e to the power of 2x plus x to the power of 4 multiplied by e to the power of x plus x squared multiplied by e to the power of 2x, subtract 2x to the power of 3 e to the x, and then subtract x squared e to the 2x, all over x squared plus e to the x. I'm not going to expand the bottom, I don't think I should yet. So this is what we've got. Okay, what can we cancel out? Well, we've got cancel out this, cancel out that. We can cancel out this because we can cancel out this, and what we're left with is this. We can't cancel any of that out. So it's 2x e to the 2x plus x to the power of 4 e to the x, all over x squared plus e to the x squared. Now I'm going to factor out an x from each of these and the e to the x from each of these. So the derivative will therefore be x e to the x 2e to the x plus x to the power of 3 over x squared plus e to the x. And that is my simplified version. Okay, that is the derivative. Now for our second example, we have y equals ln of x plus square root of x squared minus 1. Just simple chain rule. Derivative of ln, the outside, is going to be 1 over everything on the inside, multiplied by the derivative of the inside. It's going to be derivative of x is 1 plus the derivative, this here, we have a square root of x, that's the same as having x to the power of a half. So we can assume that this is to the power of a half, because it is. So what we're going to have is bring the power down, leave the inside the same, take 1 off the power, take 1 is negative a half, and then multiply by the derivative of the inside, which would be 2x. We can cancel the half and cancel the 2, and this is what we're left with. So 1 over x plus square root of x squared minus 1 multiplied by 1 plus x over square root of x squared minus 1, and that will look like 1 plus x squared minus 1 x plus x squared minus 1. I feel like that's simplified. I don't want to do anything more to that. I don't want to go on too much of this more with this question. I like the way that looks, so I'm going to leave it. I should write it like that though, because we're going to multiply the whole thing on top. Okay, so that's example 2 done. By all means, if you can simplify it further and you want to simplify it further, do that. Better to you, more power to you, but I just simplified it to that stage. So now we have y equals log base of 10 square root of x. Now, I'm just going to use a bit of log laws just to get it down first, because most people like to deal with this problem using natural logs, or it's just easier sometimes, and I'm going to show you how to do that. So first of all, this is the same as log to the base 10 x to the power of a half. Now, when you have this, this is, I haven't derived it yet, this is still the original function. Log laws means if this x is has a power, we can actually bring that power down the front and multiply it onto it. That's the exact same. These are all the exact same. Okay? Now what I'm going to use is the change of base rule, which means I'm going to change this bit. So I'm going to multiply it. I'm going to use ln of x over ln of 10. What I've done here is you have a log on the top and a log on the bottom. You have your variable on the top part and you have your base on the bottom part. Essentially, you get to choose your base. I've written natural log, so I've chosen log to the base of e, which equals the natural log. Okay? That's what I've done here. Change of base means you use the base as part of the log. You take the base and turn it not into a base. So because you can't deal with, I'm spitting too much. Basically, look up the rule. You do this process to make both of them have the same base, because you don't want to have this rubbish. Anyway, that's the change of base rule. Okay, now we've got ourselves if I put this together, we have an ln of x over 2 ln 10. Quotient rule. Now, the quotient rule isn't going to pull much up, and I can tell you why, because one of them's a number. So if we were to derive this, okay, so derivative is u dash v minus u v dash v squared. What we'll get, u dash, derivative of ln of x is 1 over x, multiplied by v, which is 2 ln 10, minus u, which is ln of x, multiplied by the derivative of v. The derivative of a number is 0, so this whole bit is cancelled. All over v squared, which is 2 ln 10 squared. Okay, now we bring, this is 1 over x over something, so we just bring the 1 down like that, like so. We bring the x down like so, and we have 2 ln of 10 over 2 ln of 10 squared. So we can get rid of 1 on the bottom and 1 on the top. Therefore, what we're left with is 1 over 2x ln of 10. And that's the derivative of log to the base of 10 square root of x. Okay. And that is it. That's my third example done. I hope you learnt something. It's always good to learn something, and have a good day.